Okay, new method today. This is I can see some of the struggles that we have here. My struggle right now is that we are going to have break, and we have to start talking about cylindrical method before we get to break. After break, we can review before we get to our test, do all sorts of things like that, but this is something we have to give adequate time for. I don't think that this is really all that bad, but I think that the most difficult part, which as I've spoken with people about, is the is being able to view it. So you guys have seen a disc method, you've seen a washer method. Today we look at a shell or a cylinder method. This is not the recommended method of choice. Oh, the food. That's right. I do owe some people some food. Namely, the group that took first place, which was Stuart. What kind of food would you like? What candy bar would you like? Butterfingers. Whitest, what would you like? Crunch. Sammy. Oh, you said that I got you bad Butterfinger bar. I got you sick. Butterfinger. Wow, you guys are disgusting. And I believe that the group that finished second would have been these three guys right here. Galen and Evan, you guys even lacked a valiant effort in this case, I believe. So, Mr. Lori, what would you like? Harris, what do you want? Reese's. And Mr. Blake? I don't care. Twix. Very good. Make me. We use shells or the cylindrical method when our disc or our washer method doesn't work. And so I'm going to start by showing you a problem where the disc nor the washer method will work. And I hope that you see why it doesn't work. This will be very important to us. So I'm going to draw an axis here. Okay. And we're going to look at the function y equals 2x squared minus x to the third. Y equals 2x squared minus x to the third. From 0 to 2, around the y-axis. So this is the really important part that you understand is why this won't work, okay? If I were to take this shape, which is really this area right here, and I were to revolve it around the x-axis, now I would come up with a shape something like that. Okay? And as you can see here, if I can try to draw something somewhat, I don't know what you would really call it. But whatever you would call it, we got this bowl shape here, okay? And the fact of the matter is that we have great difficulty being able to calculate this volume. And here's why, okay? If you simply look at this portion, you can tell what's going to happen. If we were to slice it, we would get this shape. if we were to slice it, we would get that shape, right? And we would slice it horizontally. Well, when you slice it and you look for the washer, you would have, this is our y-axis, which is x is equal to 0. This is our inner radius, our small radius, which is the function, right? So we have y equals 2x squared minus x to the third. And that also happens to be the outside function. Okay? So we have two problems here, okay? First of all, I want you to notice the first problem. First problem is that the inside radius and the outside radius are the same. The second piece that I want you to understand is this. If you're going to revolve this around the y-axis, what do you have to solve for, x or y? You have to solve for x. So could you take this thing and solve it for x equals? That'll be, you know, that ends up becoming difficult after a while. And in this one, you know, we could make some, you know, we could make some progress with it, but there are other situations where trying to solve for our radius could be very, very, very difficult. So let me show you a different way, okay? It could work. I will show you a better method. Here's what I'm going to do. I'm going to cut a rectangle out of here. As I cut that rectangle, as that rectangle rotates around, what shape does it make? Yes. As I take that rectangle and I rotate it around, there's your shape. Does everybody see that if I were to cut that rectangle, that's the shape that I would get as I revolve it around? That is my cylinder. And so what I want to do is I really want to take that rectangle, which produces that cylinder, and I want to integrate that all the way from 0 to 2. So if I could simply find the area of the label as I unwrap this cylinder, or the volume of this piece here, then we could integrate it properly. And so that's where we're headed now. Once we can do that, we can set it all up. Question? Right, because what's going to happen is the height of the cylinder is going to change, right? And the height of the cylinder will change as the height of our function changes. So that's what's going to make it possible. Question? This will be exact, 100%. This piece, we're going to take the width and move it to, no. We're going to take the width and move it to 0 as the number of rectangles goes to infinity. Taylor Blake, don't speak anymore. You will ruin our minds. Let's unwrap it. Let's unwrap it. I just unwrapped this this cylinder, and I'm going to start by finding the area of this wrapper. Okay? If I want to find the area, I'm going to start by looking at this piece right here, which is going to be the height. And then this piece here, which we could call the width or the length, whatever you'd like to. What is h going to be? What's going to determine my height? The y value, yeah. So the height is equal to the function, or the y value, or in this case, 2x squared minus x to the third. Everybody's got that, but this next part's a little bit confusing. How do I figure out the length of a label? This label wraps around a circle. 2 pi r. 2 pi r. 2 pi r is the circumference, right? So in order to figure out the length of this label, I have to figure out the circumference of the cylinder. The circumference is 2 pi r. So my width is equal to 2 pi r. Claire, you had a question. Okay, so 2 pi r is the circumference of that circle, which would be the entire distance around. All right? And what? Ask it. This cylinder right now, you're viewing it as width. Okay? You're viewing it as width. We're going to push that width to 0. So it won't matter. Okay? All right. So here's the part you have to connect for your understanding then. We have to come up with our r value. Look at this. R is the distance from the center to where we're evaluating the function. What is the distance from here to where we're evaluating the function? A for the day who comes up with it. X. Simply the x value that you would plug in to evaluate your height, that is going to be our r value. So in other words, the width is equal to 2 pi times x. So how do we figure out the area of that shape? If you guys know, the area of a label that's wrapped around a cylinder is 2 pi times r times h. In this situation, we figured out r to be x, and we figured out h to be f of x, our function. What is the width? What is the width of this rectangle? This is the general form for the volume of a cylinder. General form, if we're going to use the cylindrical method, this is generally what we use. And we say the integral from a to b of 2 pi x times f of x dx, where x represents our radius and f of x represents the height. That's where we gather it from. We can now use this information to evaluate that volume, which first appeared to be pretty difficult. Let's look at our original problem. What are our bounds of integration? 0 to 2. What can I do with that 2 pi? Move it out front. My radius is x. What is the height of the rectangle going to be? The function, which is 2x squared minus x to the third, dx. There we have it. I've set up my integral. Now we just evaluate it. Guys, What is the antiderivative of 2x to the third? 2x to the fourth over 4 minus x to the fifth over 5 evaluated from 0 to 2. 2 to the fourth is 16 times 2 is 32. Divided by 4 is 8. So I have 2 pi times 8 minus 32 over 5. Forty over 5 minus 32 over 5 is 8 over 5. 2 pi times 8 over 5. 16 pi over 5. Kids. The radius, once again, we calculated by simply labeling it as x. The height was the function. That's what makes this possible, is as we transform it here, we come up with that shape. So I just want you to understand something. With this, we've now taken a cylinder. You could integrate any shape. Let's say that the shape makes a trapezoid. Fine. Let's say that you can integrate an oblique triangle by using 1/2 AB sine of C. You can integrate any shape that you can find the area of and come up with volume. We just chose to use a cylinder. You ready to try one? Okay, take this shape. Y equals x minus x squared. Revolve it around the y-axis. From 0 to 1. Use the cylindrical method. So you can take this piece, rotate it around the y-axis, see if you come up with a volume. Do exactly like what we just did. I just changed the problem a little bit. Actually made it slightly easier. I will pause it. If you need help setting it up, let me know. Raise your hand if you got pi over 6. Good job. Is there any questions from somebody how I came up with pi over 6? I'm not going to work through the whole thing, but I will set up the integral for you. We are integrating from 0 to 1. A lot of questions came up about how do we know that's a shape. The reason why I knew it was a shape is I factored it. 0 equals x times parentheses 1 minus x. So I knew the x-intercepts were at 0 and 1, and it went above the x-axis then in between there. So that's the reason why we know it's that shape. 2 pi times our radius is x, and the height is the function, which is simply x minus x squared. From there, we distribute our x, pull the 2 pi out, antiderivative, evaluate, done. You guys are ready for a harder problem? Okay, let's look at the area bounded by y equals x. This is one of your guys' favorites. And y equals x squared. Revolved around the y-axis. We've done this problem a number of different times. And you could do this using the washer method. We're going to do it right now, showing you using the cylindrical method. If you can use both, then use whichever one you want. But really, when you can't solve for a radius using the washer method, try the cylindrical method. Yeah, if we graph this, y equals x looks like that. So you guys can see the discipline in trying to set it up appropriately. But in order to find exactly where these two spots intersect, again, you would take x squared equal to x, subtract over the x, and you get x times x minus 1 is equal to 0. You have bounds of integration from 0 to 1. So this coordinate here is 0, 0. This coordinate up here is 1, 1. That happens to be what they share in common. Now we're going to spin this around the y-axis. And so you're going to come up with, you know, that type of shape. And as you spin it, you know, again, we're going to get this bowl type shape here. And you could slice it vertically. You could. I'm sorry, slice horizontally and come out with washers that look like this. So that's one way to do it. And that's the way we practiced before. We sliced this thing. We came up with horizontal washers. But the difference is we had to solve for what variable? We had to solve for x. X is equal to something in terms of y. You could do that in this situation, but I could just modify this you know, very quickly, and you would come up with something that would be much more difficult to actually integrate and find a radius. So let's practice this using a cylindrical method. Here's how I do it. Okay, so here's how I show my work. I take this piece and I cut a rectangle out of it. That's my rectangle I cut out. And I spin that all the way around. And you can see when I spin it around, again, I'm going to get this shape. That's our shape. So that's what I'm visually thinking of as I'm doing this. And what we need is we need the radius, the distance from there to here. Anybody want to guess what that is? Not x, but just x. It's whatever we choose x to be. Oh, is that what I said? Sorry. So not x squared, but just x, whatever we choose x to be. All right? Because remember that the area of that wrapper is going to be equal to 2 pi times the radius times h. And you guys told me that the radius is going to be x, whatever we choose to evaluate x as. Now, the height, well, that's a different scenario. What's that height? Good, the top function minus the bottom function. That's my height. So when I take this and I want to integrate it, the first thing that I think about when I do the problem is, okay, I get this cylinder. Because again, you guys are asking, well, how am I going to know what to do when? Well, you got to slice it some way and then make your decision based off your slice and how you rotate it. You got to be able to try to visualize that three-dimensionally. So it looks like I could set up my volume function, which is going to be volume is equal to the integral from 0 to 1 of 2 pi times my radius, which is x, times my height, which is x minus x squared, dx. I've set it up. Yes, it is the same area. Oh, if we were to do the washer method, oh, that's no problem at all. If we were to do the washer method, um, right, no. So that's 0. So your first washer would be from here to here, or your first race would be from here to here, which is just y. Well, and then your other one would be square root of y, because you would solve by square rooting both sides. Okay. As you guys solved for this, you came up with pi over 6 again? That is the correct answer. It sounds like you're ready to practice a few of these. I'll give you a couple problems out of your assignment. We only have one more type to do after this. So, question? Not all of them, no. For example, Max, the first problem that we did, this is not going to work using a washer method. I don't believe so. But um, the reason, could you evaluate many of them? Yes. Every single one, I don't believe so. I'm trying to run my mind through every single problem in the situation. So I don't think so. I think I've come up with a few in my head that do not work out like that. So sorry. Okay. Okay, YouTube Nation, there's your assignment. Bye-bye.